All right, so let's talk a little bit about what you've just seen. So we're now dealing with trig functions of any angle, meaning that we've moved beyond just having acute angles for our trig functions. When we were dealing with a right triangle and we were trying to find the trig function for a particular angle, by definition of a right triangle, this had to be acute. But what we're starting to see now is that if we transfer that to a coordinate plane, and we think in terms of rotation around that coordinate plane, or around that axis, then acute angles would have to stay in the first quadrant. They'd have to be less than 90 degrees. And what you're seeing in these examples is that that's not the case. So if we go back to the first example, you can see here that we had a rotation starting here. This is our standard form, or excuse me, our standard position. So we had a rotation that went beyond 90 degrees. Okay? And so now what we're starting to see is that there is a way of figuring out the trig functions for these angles that go beyond 90 degrees, that are something other than an acute angle. And when we think about this, we again have to think in terms of rotation around a circle, meaning the origin of a coordinate plane serves as the center of the circle, and this then is our, what we call our terminal side. Where this ends up will be our terminal side, and that's what is creating this angle for us. Okay? And so what they're showing you is if you know a particular point that's on that terminal side, then you can figure out the trig functions by using the x coordinate and the y coordinate, because those will correspond to legs of a right triangle that you can create. Okay, but instead of talking about a specific point with specific x and y values, what I'd like you to look at is a general form of this. In general, what were we doing here? So the first thing again is to think of this as a circle, and to think of that point that was on the circle. As it rotated, imagine that it's creating this circle. So if it were to continue to rotate all the way around, it would continue to draw this circle. Okay? And if that's the case, then that means that the hypotenuse of our triangle, which is what he found in that first example, is equivalent to being the radius of our circle. And in this case, the radius would be a 5. Okay, so if we think of it as a radius rather than a hypotenuse, then we can come up with some general formulas for our trig functions. For example, to take the sine of theta, we took the 4 over the 5. Well, the 4 is simply our y coordinate, and the 5 is simply this r value. So in general, we can say that in order to find the sine of theta, if we know this point and the ordered pair for that point that would be on the circle, then we can just say that sine is going to be y over r. Similarly, excuse me, with cosine, we took negative 3 over 5. So the negative 3 came from our x-coordinate. Again, the 5 came from our r value. And so in general terms, we would say cosine is going to be x over r. And then for tangent, since tangent is opposite over adjacent, 4 over negative 3 is really just the y coordinate over the x coordinate, and so we can generalize tangent using y over x as our formula. And again, using the idea that each of these three trig functions has a reciprocal, we can then also come up with general formulas for cosecant, secant, and cotangent by simply taking reciprocals of sine, cosine, and tangent. Okay, so there's this general formula now that if we know the ordered pair of the point where the terminal side of our angle crosses the circle that the point would make if it had a little trail on it, then we can come up with sine, cosine, tangent by using these formulas rather than having to draw it all out and create a right triangle out of it. Now, what if we say that the point creates a circle with a radius of 1? So before we had a radius of 5, right? But now we're saying, no, we don't want 5. We want a radius of 1. Okay? Then what we have is what we call a unit circle. With that radius of 1, we're saying that the circle has a 1 unit radius, and we call that a unit circle. So if we now replace all of the r's with 1 instead of 5, we would end up with sine being equal to y over 1, which means sine is really just the y value, the y coordinate of your point. Same with, okay, so you can see that there. Same with our cosine. If we replace r with 1, then cosine ends up just being our x coordinate. And so cosine is going to be that distance. Okay? And then tangent is still going to be y over x because there was no r in that formula. But now we can also replace that with sine of theta over cosine of theta. So again, this is showing us how that quotient identity comes about. The fact that the tangent of theta can be written as sine of theta over cosine of theta. Okay, and again, we can take the reciprocals of all of those for our other 3 trig functions. Okay, so on the unit circle, every point where the terminal side intersects with the circle can be represented by the ordered pair cosine theta, comma sine theta. Because we've just shown that on the unit circle, cosine theta is the same as our x coordinate and sine theta is the same as our y coordinate. Now let's talk about this unit circle just a little bit. So on the unit circle, we want to show where our special angles are, because these are going to be key measurements for us to be using as we look at our lessons coming up. So let's talk about it in degrees first. Obviously, when we start at the x-axis, we're starting at 0 degrees because that's our standard position, so we have not rotated anywhere yet. If we rotate a line that goes through our first dot there, that's a 30-degree angle. The next dot would represent a 45-degree angle, and the next dot would represent 60 degrees. So we basically have 3 of these special angles in our first quadrant. And then when we get to our y-axis, then we have our 90-degree angle, because now that's forming a right angle with our x-axis, and so that's where 90 degree is. Now we can continue going around the circle, and our next dot is going to be 120 degrees. Then we've got 135 degrees, 150 degrees, and back to another axis. So now our axis is creating a straight line. It is part of the x-axis, and therefore that's 180 degrees. We are halfway around the circle. And again, notice that there are 3 special angles in the second quadrant. And they all have some relationship to the angles in the first quadrant. We're going to see that relationship more in just a minute. Okay, continuing to go around, our next angle would take us to 210 degrees. Then we have 225 degrees and 240 degrees. So again, 3 more special angles in the third quadrant. which then takes us to our negative y-axis, which is 270 degrees. And then finally, as we keep rotating, we have 300 degrees, 315 degrees, 330 degrees. Oh, sorry, let's go back a step. And then we're back up to where we started. So in degrees, these are the special angles. These are the measures that you need to be able to identify quickly and have some idea of where they are on the unit circle. And all of these angles have relationships to each other, which we're going to see a little bit more in a minute, and we'll see even more when we get to our lesson tomorrow. Now let's talk about this in terms of our radians. Okay, same locations for our angles, for our special angles, but in radians. So again, x-axis starts at 0, but then our first rotation is going to be pi over 6, pi over 4, and then pi over 3. Okay, when we get halfway around, we are halfway to pi, so obviously that's pi over 2. And then when we continue, we've got 2 pi over 3, 3 pi over 4, and 5 pi over 6. Now look at the relationship here. Notice that this angle and this angle are in some ways reflections of each other. Not in some ways, they are. Through the y-axis, these two angles, these two terminal sides of our angles are reflections of each other. And notice that they both have the same denominator. If we look at some of the other ones, we can see that the terminal side for pi over 4 is a reflection of the terminal side for 3 pi over 4. Again, same denominator. Okay, and then if we look at pi over 3 here, we have a reflection of that here, same denominators. Okay, that's going to be really helpful to us. And again, one of the reasons why we want to be using radians when we can with our angle measures, because there's much more of a pattern with those and much more of a connection. That's going to make it easier to find the trig functions that we're looking for. Okay, so if we keep going now, halfway around our circle is going to be pi. And then we get to 7 pi over 6, 5 pi over 4, and 4 pi over 3. Again, notice the repetition of those denominators. Get to the negative y-axis, which is 3 pi over 2, and then we have 5 pi over 3, 7 pi over 4, and 11 pi over 6. Okay, once again, repeating those denominators. And that's not a coincidence. The repetition of those denominators is all going to help us with how these relate to other angles and how we're going to be able to find our trig functions when we get to this lesson tomorrow. Now, let's just talk about these ordered pair, the idea of the ordered pairs here for a second with the ones that we know. So obviously, if this is a circle with a radius of 1 coming out here like this, okay, then this point right here has to be the point 1, 0. We went 1 unit to the right, we did not go up or down, and so that's going to be the ordered pair 1, 0. Okay, when I get to my next angle, remember this is pi over 6 or 30 degrees. So we've already talked about this. This is a special angle. And we know that the sine of 30 degrees is 1/2. So that becomes our y coordinate. We know that the cosine of 30 degrees is square root of 3 over 2. So that becomes our x coordinate. So this point right here, where the terminal side intersects with the unit circle, is the point square root of 3 over 2, 1/2. Okay, and we know that because this is cosine and this is sine. And we can do that with all of these special angles. We know that the next angle is supposed to be pi over 4, and so we know that the cosine of pi over 4 is square root of 2 over 2, and we know that the sine of pi over 4 is square root of 2 over 2. So our ordered pair is going to be square root of 2 over 2, comma, square root of 2 over 2. And we know that for pi over 3, which is the same as 60 degrees, we know that cosine is the 1/2 and sine is the square root of 3 over 2. And so we can figure out the ordered pair for that point. Okay, so we already know a lot about this unit circle, about the angles, and about these ordered pairs, these sines and cosines of these special angles. We're going to build on that in our next lesson tomorrow. The other thing we can pretty easily tell are the ordered pairs of the other points at the axes. So if I'm right on the y-axis, for example, where my terminal side intersects with the unit circle is going to have to be 0, 1, because that radius again is a length of 1, but it's on the y-axis, so that's a y value now. So 0, 1 would be a point there. We'd have the point -1, 0 there, and we'd have 0, -1 there. So you should have filled this information in on your notes page with the unit circle that's given to you. If you didn't get it all down, rewind, go back, take a look at it, make sure it's all filled in, because you're going to need this information for not only tomorrow's class, but for all of the lessons coming up yet in this chapter. So you must be able to identify the approximate location of all 16 of these special angles that we've just shown you on the unit circle. You're going to see tomorrow that evaluating a trigonometric function depends on knowing the reference angle. That's something you're going to learn about tomorrow, and knowing the positive or negative sign of that quadrant. But you can only figure out what the reference angle is going to be if you know where the original angle should be located in the first place. So you need to work on knowing these angles before the next lesson. Know where they're located, know which quadrant they're in, have an approximate idea of where that terminal side should be. And then the last part of this lesson that you're going to see now is a quick little trick that may help you to evaluate trig functions more easily tomorrow. Okay, so watch this final little video clip, and then we'll see you tomorrow in our next lesson.